Namaskar, I am Anand, and all of you are in the live session of Join for Education. In this class, I am going to discuss about vectors, which is one of the most important chapter of mathematics as well as the physics. The first subtopic of this chapter is vector algebra. Put at a balance in the figure. So, if we put at a balance in this figure, then PQ. According to the mathematics, this is a ray. What here P is the initial point and Q is the terminal point. Again, we discuss about this figure. So Q2 minus P2 is the y component and Q1 minus P1 is the x component. So this is the vector PQ. So the x component of vector PQ equal to Q1 minus P1 and y component of PQ equal to Q2 minus P2. Let's go forward. Let's see the definition of vector. The family of all directed line segments with the same components as vector PQ will be called the vector from P to Q. We say that vector PQ represents this vector. So hope that there is no problem to understand the definition of the vector. If we have proper idea about the line segments and component of the initial and terminal point of a line segments, then we have no problem to understand the vector. I underlined the definition of the vector. So since all directed line segments with the same components have the same length, may be regarded as a quantity which has length and direction. Vectors arise quite naturally in both physics and economics as well as in mathematics. Here are some examples of vector quantities: position, velocity, and and acceleration, force, displacement, which is also known as the change in position, commodity vector. This is from economics, and this is price vector. Let's see the example. Component of the vectors represented by the given directed line segment. So this is the so the x component will be 5 minus equal to 2, and y component equal to 1 minus 2 equal to minus 1. Let's see for this question, x component will be 2 minus 0 equal to 2, and y component equal to minus 3 minus minus 2 equal to minus 1. If we put at a gallons, notice that both of these directed line segments represent the same vector. They are shown in figure. Let's see the figure here. In this figure, this figure and this figure. So vectors are denoted by bold face letter. Suppose A, then we read this is the bold face letter. So we say this is the vector A. A vector is represented by a whole family of directed line segments. However, given a vector A and an initial point P, there is exactly one point Q such that the directed line segment vector PQ represents bold face letter A. To find the x coordinate of Q, we add x coordinate of P and x component of bold face letter A or vector A. Similarly for y coordinate. Let's see this example. Let A be the vector with component -4 and 1. Let P be the point 1, 2. Find Q so that PQ represent bold face letter A or vector A. Q has the x coordinate 1 plus minus 4. So this is 1 plus minus 4 equal to minus 3, and y coordinate 2 plus 1 equal to 3. Thus Q minus 3, 3 as shown in figure. Let's see this is the figure 10.14. So this is the P, and this is the Q. The length of the position vector is distance from the origin. The length of a velocity vector is the speed of a particle. The length of force vector is the magnitude of the force. The length of displacement vector is the distance moved. So let's see here, force, displacement, and force, displacement, and a speed. A speed, force, displacement, all of these are the length. Of that there is no problem to understand. So the length of a position vector is the distance from the origin. The length of so this is the A1, this is the A2. So length of a vector equal to A1 square plus A2 square over root. The length of a velocity vector is the speed of a particle. The length of a force vector is the magnitude of the force, and length of the displacement vector is the distance moved. If anybody asks us what do you mean by length of a displacement vector is the distance moved, length of the velocity vector is the speed, and length of the force vector is the magnitude of the force. Up here we are seeing that acceleration is not given. Let's see one example. The vector A with component 3 minus 4, then the length of the vector A will be a square of 3 plus a square of minus 4 over root. So a square of 3 is 9, and a square of minus 4 is 16. 9 plus 16 equal to 25, and the square root of the 25 is 5. The vector with the component 0, 0 is called 0 vector, denoted by boldface letter 0. The 0 vector is represented by the degenerate line segment vector EP. It has no direction. So 0 vector has no direction, but it has the length of the 0 vector is 0. So the magnitude is 0 and no direction. Then 0 vector is, as per the definition of the scalar and vector, this one can be a scalar too, while the length of every other vector is a positive scalar. While the length of every other vector is a positive scalar. It will be a scalar. It means that it has magnitude but no direction. But in the case of 0 vector, this is no direction. So let's see the discuss about vector A plus vector B. A and B is defined as follow. Let PQ. This is the PQ. AB and represent A and let QR represent B, then A plus B is the vector represented by P R. More briefly, if A is the vector from P to Q and B is the vector from Q to B, from Q to R, then A plus B is the vector from P to R. Let's see the figure. Vector A from P to Q, vector B from Q to R, and vector A plus B from P to R. Vector sum of a rule similar to the rule for sum of real numbers. Let's see the theorem 1. Let A, B, C be vectors. Identity law A plus 0 equal to 0 plus A equal to A. Commutative A plus B equal to B plus C. Associative A plus B plus C equal to A plus B plus C. Triangle inequality magnitude of A plus B less than equal to vector A plus vector B. This is the triangle inequality. A plus B equal to A plus B. A B C equal to A plus B plus C. A B C D E equal to A plus B plus C plus D plus C from A to E. A plus B plus C equal to 0. A plus B plus C plus D plus C equal to 0. So PQ equal to A and QP equal to minus A. The sum of vectors clockwise or counterclockwise around the perimeter of a triangle or polygon is always the zero vector. We next define the vector negative. minus A and vector difference B minus A. If A is the vector from P to Q, then minus A is the vector from Q to P. So B minus A is the vector which when added to A gives B. A plus B minus A equal to B. We cancel out A, then we get B. Thus, if A is the vector from P to Q and B is the vector from P to R, then B minus A is the vector from Q to R. This is the vector difference. A plus B minus A equal to B. This is the theorem to let A be vectors minus 0 equal to 0 minus A equal to A minus A equal to 0, B minus A equal to B plus minus A. Rule 4 is illustrated in figure 10.114. This is A plus B minus A equal to B and minus A plus B plus minus A equal to B. For more details, book your online live class. For more details of these topics, book your online live class.